Today we are looking at a $5,000 enterprise conference camera. And it features this massive, pristine 4K image sensor, but it intentionally downgrades its own footage to 1080p before you even see it. So welcome to the deep dive.
Yeah, thanks. And I know it sounds like a terrible business model at first glance, right?
Right. Why pay for 4K if you aren't getting 4K?
Exactly. But unpacking this specific camera, the QSC NC-12x80 PTZ, it completely shifts how we think about enterprise AV. I mean, we are really moving out of the era of basic hardwired computer webcams.
Yeah, and stepping into this realm of highly intelligent, autonomous network environments.
Right.
So before we get into how it connects to a network, we should probably talk about what it's actually capturing. It has this motorized pan, tilt, and zoom, and specifically a 12x optical zoom.
With an 80-degree horizontal field of view, yeah. Which are pretty standard premium specs.
They are, but the optical zoom is key here. I always like to say, digital zoom is like taking a grainy photo and just stretching it out.
Yeah, it looks terrible. It really does. Well, optical zoom is, well, it's like using a telescope to physically move the viewer closer to the subject.
Exactly, using the actual glass. But that brings us back to the specs and that deliberate 1080p downgrade you mentioned. Why pack an expensive 4K sensor in there just to throttle the output?
Right. What's the point?
It really comes down to data management. Pushing raw 4K video across a massive corporate network it chews up precious bandwidth.
Oh, sure. I mean, if every boardroom was streaming 4K, the network would just completely bottleneck.
Precisely. So by capturing in 4K and downsampling to a 1080p stream right at the hardware level, the camera does something called pixel binning.
Wait, pixel binning?
Yeah, so it essentially combines the data from multiple pixels into one, and that drastically reduces image noise, which is, totally crucial for those dimly lit, cavernous boardrooms.
Okay, so you get the absolute cleanest 1080p possible, rather than sending this noisy, compressed 4K signal that your conferencing software is just going to aggressively compress again anyway. You got it. It's about optimizing the quality where it actually impacts the end user.
But capturing a pristine image introduces a major logistical headache, right? Because you still have to get that data from a wall-mounted camera all the way over to the computer.
Right, the physical transport.
And if there is one universal truth in IT, it's that running a 50-foot USB cable across a ceiling is an absolute nightmare.
Oh, they degrade and fail constantly. It's the worst.
So how does the NC-12x80 actually bypass that?
Well, it uses the QSYS ecosystem approach. So it ditches the USB in the room entirely and relies on a single standard network cable.
Oh, wow. Just one cable for everything.
Yeah, just one.
Yeah.
It handles the video transport, the control data, and even power over Ethernet. It routes that high-quality feed over the IP network and delivers it to the PC via a local network to USB bridge.
Wait, really? So if it's acting as a standard IP node, I don't actually need a dedicated physical wire going from the camera to a specific PC?
No, you don't. And that is the real paradigm shift here. Historically, routing multiple cameras to different screens required these massive, expensive hardware video matrix switchers.
Oh, yeah. Kind of like old physical telephone switchboards where lines had to be manually patched together.
Exactly. But here, the IP network itself is the switcher. It routes packets of video data, much like, well, like modern cellular networks route data.
Meaning any authorized PC on that network that has a bridge can just request the camera's IP address and pull the feed. So it's a many-to-any setup.
Assuming you have the network permissions, yes.
I mean, you could theoretically pull a boardroom camera feed onto a laptop across the entire corporate campus.
You absolutely could. It completely divorces the optical hardware from the local compute hardware.
That is wild. Okay, so the hardware is secure, the network is streamlined, but how does the camera actually interact with the humans in the room?
Well, this brings us right back to that 4K sensor overhead we talked about, because that overhead powers the auto-framing feature.
Right, and that has universal compatibility with the platforms you're probably already using, like Microsoft Teams, Zoom, Google Meet.
Yeah, all of them. Because of that massive sensor resolution, the camera can digitally crop and reframe the shot without ever dropping below true 1080p fidelity.
Oh, so when auto-framing is turned on, it acts like a built-in invisible film director.
Exactly. If a third person walks into a meeting room, the camera just autonomously widens the composition to capture all the detected faces. There are no remote controls, No manual presets to mess with.
It just constantly adjusts, so the remote participants always have the optimal view. I mean, by combining the premium optics with this really smart network integration, it essentially removes the friction of the technology itself.
It really does. It completely redefines the modern meeting space.
It absolutely does.
And, it leaves a really fascinating thread to pull on for everyone listening.
Oh, what's that?
Well, as these cameras transition from being simple USB peripherals into these highly intelligent autonomous network nodes that are making real-time decisions, how long until remote collaboration feels utterly indistinguishable from sharing the exact same physical room?
Man, that is a great question. It really makes you rethink what a camera even is in the modern enterprise.
Well, thanks for joining us to explore this, and we will catch you on the next deep dive.